So good afternoon and good evening, dear students. How are you? This is Teacher Elfaz. As you know, we are in senior two, where we are going to continue with bonding in chemistry. First of all, bonding is about what? You remember when we introduced bonding, is about connecting two or more things together to produce one thing. Let's give an example. You know, a zip is having two parts, the right part and the left part. And when we connect them together by using a zip, we get only one thing. That is a kind of bonding where we bond the one drive and another second drive. To that extent, we are going to see how atoms can join and can connect together. When atoms connect together, they get a stable and a molecule which result to the connection of different atoms, which result to the formation of the most stable structure. In another way, as we will continue to work on, we shall see that in a normal way, in a Weber situation, the atoms are not stable. Why atoms are not stable? As we have seen in the previous lesson about atoms, the atoms are not stable due to their electronic configuration, which make them not to be stable. The stability of an atom, you remember, depend on that we call the octet rule or rule of 8, whereby each atom will be stable when it has only 8 electrons on its outermost shell. To that, you remember when if I can remind you about periodic table. Remember, this is about chemical bonding, that's interaction which occur whereby associating atoms together. When atoms are associated together, they form molecules or ions or they form crystals, which are be stable structures or stable species that will make the familiar substances of everyday world. This means that whatever we do in our everyday world means it depend on the bonding of atoms. The atoms exist in different structures, especially they exist in different that you call groups. I think you remember this is group 1 alkynes, that's at group 2 alkaline earth metals. This is from here, those are called the transition metals. Those transition metals depend on the classification. This is group 3, this is group 4, this is group 5, this is group 7, 6, this is group 7, this is group 8. Those elements which are in the middle, they are transition. So we shall see in our coming lesson why I them called the transition metals. Then, to that extent, I want to explain to you that when we talk about bonding, we are going to see that we call ions first of all. What is an ion? An ion is an atom or group of atoms which have been connected together. Remember, those atoms or group of atoms are not stable. That's why they're called ions. This means they depend on the number of electrons which are having on the various shell electrons on their outermost shell. This means that those number of electrons will make an atom not to be stable because they have either lost or gained. This means an atom can be more stable than an ion can be more stable than an atom. We shall say an example whereby an atom of magnesium, for example, is having 2 electrons, 8 electrons, and 8 electrons. That is magnesium 2 plus means the 2 electrons have been lost. When they are lost means it is having 8 electrons on outermost shell as the main which explains the stability of an atom. So after defining an ion, we have that we call valence shell electrons. The valence electrons, that's to find the number of valence electrons in an atom which are representative. Then we look on its group number. Remember about group numbers, about of vertical lines and the horizontal lines. Those are the periods, those are groups, those are the periods. Means the group of a number which gives the electrons. This is what I was telling you about the octet rule, whereby an octet rule is an element or a group of atom which is made by a noble configuration of atom or a noble gas configuration. This is about having 8 electrons on outermost shell, which is again called the octet rule. How to find the outermost shell electrons? This means here we are having, like you see here, this is the nucleus of an atom. This is the outermost shell. You see the first shell is having one electron. This is about the hydrogen atom. You see, for example, for carbon, this is the inner protons. Those are outermost shell, whereby the first shell, this first circle, is made by 2 electrons. Then the second shell is made by 4 electrons, which will be the outermost shell, which can hold 8 electrons. We have nitrogen, where the first one is having 2, then the second one is having 5. We have about oxygen, where the first one is having 2 electrons. As a rule, you see always the first one, apart from hydrogen, always the first shell is having 2 electrons, 2 electrons, then 2 electrons. Then the second shell can have either 2 or 3 or 8, depending on the atomic number of a given atom. Then how to explain the octet rule? You see, octet rule is atom which tends to gain or to lose 8 or to share the electrons in order to have the 8 electrons on outermost shell. For example, you see for this case of carbon, here hydrogen cannot, because you see hydrogen cannot have 8 electrons, means it cannot accept 7 electrons, yet it can even lose 1 electron, but the 7 electrons cannot be accepted. Even we are in the first shell, and you see that always the first shell is accommodating the maximum of 2 electrons. You see, for the example here for carbon, it is having the 6 electrons on the maximum, whereby the first shell is made by 2 and the second shell is made by 4. Means to make 8, it can gain again 4 electrons. Nitrogen can gain 3 and the oxygen can gain 2, like chlorine can gain 1, fluorine can gain 1, phosphorus can gain 3. Then you can have the different examples. Then when it gains, it is an ion which will gain or lose in order to make or to stabilize its outermost shell. What to check out? On the key concept, atoms of metals loses their valence electrons. Always the metals they lose. You remember the metals are for group 1, group 2, and group 3. Atoms of some nanometal tend to gain electrons or to share with other nanometal elements to achieve the complete octet rule. This means simply means metals lose, whereas nanometals gain. So shall see that when you form a cation, you know a cation is formed when an atom loses electrons. You see, for this case, we are having here, for example, sodium in its natural state is having the charge of 0. Then, whereas here, sodium after losing 1 electron, it will be having a charge of positive 1 because the number of protons are greater than the number of electrons we are having in our molecule. Then you see the electrons in terms of removal of atom. You see here inside we have positive 11 protons and you have negative 11 electrons. It means the result is 0. That is before losing. So after losing, you see that you have protons which are 11, and after losing we are remaining 10 electrons. If you make the difference, we shall remain with positive 1. This is the illustration we are having at this case. We have that on this side we are having sodium positive after losing 1 electron. So to that we have also formation of an anion. Anion is about to gain. When to gain 1 electron, you see for this case, chlorine is having 1 electron. Then after getting another one, it is having this structure. It will be, then we consider also how the electrons will change. You see, they have 17 proton and 17 electrons. The result is 0 because before losing. But after losing, we have 17 proton and 18 electron, which means the result will be negative 1, negative 1. This is about the formation of anion. About Lewis structure and dot and cross, this means you have valence shell electrons. Like on this case, we have 2, we have 6, we have 2. This means the first shell is made by 2 electrons, which is represented by 1s2. The second is made by 8 electrons, whether it was 2 plus those 6, whereas the third one is made by 2 electrons. Then the two electrons of last shell, Those are the two dots we have represented for magnesium because we represent only, sorry, because we represent only the two electrons of outermost shell. This is about the dot and cross diagram about the presentation of atom. This is about the general structure where the electrons are represented in different dot and cross, that from what group 1 lithium, that is hydrogen, lithium, sodium, potassium, rubidium, and caesium. This group 2, that's the beryllium, magnesium, calcium, strontium, and barium. Those about cation after losing 2 electrons in a representation dot cross. Group 3 have boron and aluminium. Group 4 have carbon and silicon. Group 5 have nitrogen, phosphorus. Group 6 have oxygen, sulfur, selenium, and therium. And the group 7 you have fluorine, chlorine, bromine, and iodine. So those are group 8, which are noble gas called, they are helium, neon, argon, krypton, and xenon. Where you're having that, you're having 8 dots, which are meant in four orientation, 2, 2, 2, 2, which make them 8. This is about dot representation of atoms. What is an ionic bond? An ionic bond is composed by cation and anion, as we saw. Remember, anion is formed by gaining, whereas cation are formed by losing. Means when those forces, those an atom which lost, another one which have been which gained, when they connect together through an electrostatic force which will hold those ions together, they form an ionic bond. In definition is what is an ionic bond? Is an electrostatic force that holds the ions together after they have lost or gained their electrons. In this case, we have ionic bond. What do we have to think? You see, we are having this dog, which we consider to be chlorine. You see, we are having this also dog, which are having this bone, and this one is a bone. Then this one is chlorine. It is missing something to complete. This means when you take this bone and this one you connect it here, it will become a full bone after joining them together. This means a unit of formula which will result from bonding those two atoms, we get that we call ionic bonding. Chemical formula show the kinds of number of atoms in the smallest representative unit of substance, which is because an ionic compound exists as a collection of positive and negative charged ions arranged in repeating patterns. Its chemical formula, which is referred to the ratio, that the formula unit. Then we shall see that the formula will depend on the ratio of the atom, the electrons lost and gained. Means here, for example, sodium and chlorine. You see here, sodium have lost 1 electron, then chlorine have gained 1 electron. If they connect them together, they have in ratio 1, 1. Means 1 electron lost, 1 electron lost. This means we write 1, 1, and we write sodium and chloride together. So, as we continue, you see in practice, you use electron dot structure to determine the formula of ionic compound formed by potassium, which react with iodine, and aluminium react with oxygen by joining the dot and cross. This is the activity you shall do in your free time. Then what are the properties of ionic bonding, which result from the connection or the link between the two atoms? Means those are more crystalline, they are solid at room temperature, they have the higher boiling point and melting point, they conduct electricity when they are in molten state, and or when they are dissolved in water, means when they are in solution. So after this, we can see another practice. So you write a formula of each of the compound, like barium chloride. You shall write a formula in your free time. Lithium oxide, magnesium oxide, and calcium fluoride. Those are how the atoms have been connected together. So then for bonding in metals, this means those metals have been bonded together, then they form that we call metallic bonding. But I think this chapter we shall continue to see it next time. I think we can see that we can see another property of ionic bonding. So whereby we can observe or we can watch this video that I want to share with you. that we are going to see the properties of ionic compounds. Let us see our YouTube video that I have uploaded for you, so that you can watch that video. Then after watching it, you shall observe the properties of an ionic compound. Yeah, let us wait for the YouTube to be opened, because I have uploaded your video. Internet is not working. I don't know, even the test is going back. Internet connection. Yes. Come here home. Make search. Then properties of ionic compounds.
Hi and welcome back to freesciencelessons.co.uk. By the end of this video, you should be able to describe how ionic compounds form giant ionic lattices. You should then be able to explain why ionic compounds have got high melting and boiling points. And finally, you should be able to explain why ionic compounds cannot conduct electricity when they're solids, but they can conduct electricity when they're molten or dissolved in water. We've been looking at ionic bonding, which takes place when a metal reacts with a non-metal. A good example is the reaction between sodium and chlorine. In this reaction, one electron passes from the sodium atom to the chlorine atom like this. At the end, the sodium atom has a 1 positive charge, and we now call this a sodium ion. Remember that an ion is an atom with a charge. The chlorine atom now has a 1 negative charge, and we call this the chloride ion. In this reaction, we make the compound sodium chloride, which looks like this. As you can see, sodium chloride is a crystal, and in fact many ionic compounds form crystals like this. So in this video we're looking at how the ions are arranged in a crystal and how this determines their properties. The first key fact is that ionic compounds form giant structures where every positive ion is surrounded by negative ions and vice versa. I'm showing you that here for sodium chloride. So we've got positive sodium ions surrounded by negative chloride ions. Scientists call this a giant ionic lattice. Giant ionic lattices are three-dimensional. The second key fact is that giant ionic lattices have got very strong forces of attraction between the positive and the negative ions. Scientists call these electrostatic forces. I'm showing you these forces here. These strong electrostatic forces hold the positive and negative ions in place. We call these electrostatic forces ionic bonds, and they act in all directions. We can also represent giant ionic lattices like this. Here we're not showing the electrostatic forces, but we know that they're there. Now there are two key properties of ionic compounds which we need to look at. The first is that ionic compounds have got very high melting and boiling points. That's because the strong electrostatic forces require a great deal of heat energy to break. I'm showing you that here. As we heat the ionic solid, the particles vibrate. When the particles vibrate with enough energy, the electrostatic forces break and the solid melts. However, this requires very high temperatures because the electrostatic forces between the ions are very strong. A good example is sodium chloride. The melting point of sodium chloride is around 800 degrees Celsius. The second key property of ionic compounds is that they cannot conduct electricity when they're solids. That's because the ions cannot move. They're locked in place by the strong electrostatic forces of attraction. However, ionic compounds can conduct electricity when they're melted or dissolved in water. That's because now the ions can move and carry the charge. Now this often comes up in the exams and students frequently get this wrong. You need to remember that when ionic compounds conduct electricity, it's the ions that move, not electrons. You'll find plenty of questions on ionic compounds in my revision workbook, which you can get by clicking on the link above. Okay, so hopefully now you should be able to describe how ionic compounds form giant ionic lattices. You should then be able to explain why ionic compounds have got high melting and boiling points. And finally, you should be able to explain why ionic compounds conduct electricity when molten or dissolved in water, but cannot conduct electricity when they're solids.
So I think also by those different videos that which have been posted for you, you can still watch, and then I can give you the link where you can be observing those videos where we are talking about different bonding and their properties. This was about ionic compound and their properties. I think next time we shall see and we shall enjoy another session about the covalent bonding and the giant structure. Thank you very much. Have a good evening.